Integrated Services for Digital Network is a set of communication standards for simultaneous digital transmission of voice, video, data, and other network services over the traditional circuits of the public switched telephone network. It was first defined in 1988 in the CCITT Red Book. Prior to ISDN, the telephone system was viewed as a way to transport voice, with some special services available for data. The key feature of ISDN is that it integrates speech and data on the same lines, adding features that were not available in the classic telephone system. There are several kinds of access interfaces to ISDN defined as basic rate interface, primary rate interface, narrowband ISDN, and broadband ISDN. ISDN is a circuit-switched telephone network system, which also provides access to packet-switched networks, designed to allow digital transmission of voice and data over ordinary telephone copper wires, resulting in potentially better voice quality than an analog phone can provide. It offers circuit-switched connections, and packet-switched connections, in increments of 64 kilobit per second. A major market application for ISDN in some countries is Internet access, where ISDN typically provides a maximum of 128 kbit per second in both upstream and downstream directions. Channel bonding can achieve a greater data rate. Typically the ISDN B channels of 3 or 4 bris are bonded. ISDN should not be mistaken for its use with a specific protocol, such as Q931, whereas ISDN is employed as the network, data link and physical layers in the context of the OSI model. In a broad sense, ISDN can be considered a suite of digital services existing on layers 1, 2, and 3 of the OSI model. ISDN is designed to provide access to voice and data services simultaneously. However, common use reduced ISDN to be limited to Q931 and related protocols, which are a set of protocols for establishing and breaking circuit-switched connections, and for advanced calling features for the user. They were introduced in 1986. In a video conference, ISDN provides simultaneous voice, video, and text transmission between individual desktop video conferencing systems and group video conferencing systems. ISDN elements. Integrated Services refers to ISDN's ability to deliver at minimum 2 simultaneous connections, in any combination of data, voice, video, and fax, over a single line. Multiple devices can be attached to the line, and used as needed. That means an ISDN line can take care of most people's complete communications needs at a much higher transmission rate, without forcing the purchase of multiple analog phone lines. It also refers to integrated switching and transmission, in that telephone switching and carrier wave transmission of integrated rather than separate, as in earlier technology. Basic rate interface. The entry-level interface to ISDN is the basic rate interface, a 128 kbit per second service delivered over a pair of standard telephone copper wires. The 144 kbit per second payload rate is broken down into 264 kbit per second bearer channels and one 16 kbit per second signaling channel. This is sometimes referred to as 2B plus D. The interface specifies the following network interfaces. The U interface is a 2-wire interface between the exchange and a network terminating unit, which is usually the demarcation point in non-North American networks. The T interface is a serial interface between a computing device and a terminal adapter, which is the digital equivalent of a modem. The S interface is a 4-wire bus that ISDN consumer devices plug into. The S and T reference points are commonly implemented as a single interface, labeled ST, on a network termination 1. The R interface defines the point between a non-ISDN device and a terminal adapter which provides translation to and from such a device. BRIISDN is very popular in Europe but is much less common in North America. It is also common in Japan, where it is known as INS64, primary rate interface. The other ISDN access available is the primary rate interface, which is carried over an E1 in most parts of the world. An E1 is 30 channels of 64 kbit per second, 1 D channel of 64 kbit per second, and a timing and alarm channel of 64 kbit per second. This is often referred to as 30B plus D. In North America, pre-service is delivered on one or more T1 carriers of 1544 kbit per second. A pre has 23 B channels and 1 D channel for signaling. Interchangeably but incorrectly, a pre is referred to as T1 because it uses the T1 carrier format. A true T1 uses 24 channels of 64 kbit per second of in-band signaling. Each channel uses 56 kilobits for data and voice and 8 kilobits for signaling and messaging. Pre uses out-of-band signaling, which provides the 23 B channels with clear 64 kilobits for voice and data and 164 kilobits D channel for signaling and messaging. In North America, non-facility associated signaling allows two or more pre to be controlled by a single D channel, and is sometimes called 23B plus D plus N asterisk 24B. D channel backup allows for a second D channel in case the primary fails. NFAS is commonly used on a T3. Pre-ISDN is popular throughout the world, especially for connecting private branch exchanges to the public network. Even though many network professionals use the term ISDN to refer to the lower bandwidth BRI circuit, in North America BRI is relatively uncommon whilst pre-circuits serving PBXs are commonplace. Bearer channels. The bearer channel is a standard 64 kbit per second voice channel of 8 bits sampled at 8 kHz with G711 encoding. B channels can also be used to carry data, since they are nothing more than digital channels. Each one of these channels is known as a DS0. Most B channels can carry a 64 kbit per second signal, but some were limited to 56 K because they traveled over RBS lines. This was commonplace in the 20th century, but has since become less so. Signaling channel. The signaling channel uses Q931 for signaling with the other side of the link. X25. X25 can be carried over the B or D channels of a BRI line, and over the B channels of a pre-line. X25 over the D channel is used at many point-of-sale terminals because it eliminates the modem setup, and because it connects to the central system over a B channel, thereby eliminating the need for modems and making much better use of the central system's telephone lines. X25 was also part of an ISDN protocol called Always On Dynamic ISDN, or AU-DI. This allowed a user to have a constant multi-link PPP connection to the Internet over X25 on the D channel, and brought up one or two B channels as needed. Frame relay. In theory, frame relay can operate over the D channel of BRIS and PRE, but it is seldom, if ever, used. Consumer and industry perspectives. There is a second viewpoint, that of the telephone industry, where ISDN is a core technology. A telephone network can be thought of as a collection of wires strung between switching systems. The common electrical specification for the signals on these wires is T1 or E1. Between telephone company switches, the signaling is performed via SS7. Normally, a PBX is connected via a T1 with robbed bit signaling to indicate on-hook or off-hook conditions and MF and DTMF tones to encode the destination number. ISDN is much better because messages can be sent much more quickly than by trying to encode numbers as long tone sequences. This results in faster call setup times. Also, a greater number of features are available and fraud is reduced. ISDN is also used as a smart network technology intended to add new services to the public switched telephone network by giving users direct access to end-to-end circuit-switched digital services, and as a backup or fail-safe circuit solution for critical use data circuits. ISDN and broadcast industry. ISDN is used heavily by the broadcast industry as a reliable way of switching low-latency, high-quality, long-distance audio circuits, in conjunction with an appropriate codec using MPEG or various manufacturers' proprietary algorithms. An ISDN BRI can be used to send stereo bidirectional audio coded at 128 kbit per second with 20 Hz to 20 kHz audio bandwidth. Although commonly the G722 algorithm is used with a single 64 kbit per second beat channel to send much lower latency mono audio at the expense of audio quality. Where very high-quality audio is required, multiple ISDN BRIs can be used in parallel to provide a higher bandwidth circuit-switched connection. BBC Radio 3 commonly makes use of 3 ISDN BRIs to carry 320 kbit per second audio stream for live outside broadcasts. ISDN BRI services are used to link remote studios, sports grounds and outside broadcasts into the main broadcast studio. ISDN via satellite is used by field reporters around the world. It is also common to use ISDN for the return audio links to remote satellite broadcast vehicles. In many countries, such as the UK and Australia, ISDN has displaced the older technology of equalized analog landlines, with these circuits being phased out by telecommunications providers. IP-based streaming codecs are starting to gain a foothold in the broadcast sector, using broadband internet to connect remote studios. However, reliability and latency latency is crucially important for broadcasters, and the quality of service offered by ISDN has not yet been matched by packet-switched alternatives. Countries United States and Canada. ISDN BRI never gained popularity as a general-use telephone access technology in Canada and the US, and remains a niche product. The service was seen as a solution in search of a problem, and the extensive array of options and features were difficult for customers to understand and use. ISDN has long been known by derogatory acronyms highlighting these issues, such as "it still does nothing," "innovations subscribers don't need," and "I still don't know." Once the concept of broadband internet access came to be associated with data rates incoming to the customer at 256 kbit per second or more, and alternatives like ADSL grew in popularity, the consumer market for BRI did not develop. Its only remaining advantage is that while ADSL has a functional distance limitation and can use ADSL loop extenders, BRI has a greater limit and can use repeaters. As such, BRI may be acceptable for customers who are too remote for ADSL. Widespread use of BRI is further stymied by some small North American CLECs such as Century Telu having given up on it and not providing internet access using it. However, AT&T in most states will still install an ISDN BRI line anywhere a normal analog line can be placed, and the monthly charge is roughly $55. ISDN BRI is currently primarily used in industries with specialized and very specific needs. High-end video conferencing hardware made by companies such as Sony, Polycom, Tandberg, and Lifesize via the Lifesize networker can bond up to 8-beat channels together to provide digital, circuit-switched video connections to almost anywhere in the world. This is very expensive, and is being replaced by IP-based conferencing. But where cost concern is less of an issue than predictable quality, and where a QoS-enabled IP does not exist, BRI is the preferred choice. Most modern non-VoIP PBXs use ISDN pre-circuits. These are connected via T1 lines with the central office switch, replacing older analog two-way and direct inward dialing trunks. Pre is capable of delivering calling line identification in both directions so that the telephone number of an extension, rather than a company's main number, can be sent. It is still commonly used in recording studios, when a voiceover actor is in one studio, but the director and producer are in a studio at another location. The ISDN protocol delivers channelized, not over the Internet service, powerful call setup and routing features, faster setup and teardown, superior audio fidelity as compared to POTS, lower delay, and, at higher densities, lower cost. In 2013, Verizon announced it would no longer take orders for ISDN service in the northeastern United States. India Bharat Sanchar Nigam Limited, Reliance Communications and Bharti Airtel are the largest communication service providers, and offer both ISDN BRI and PRE services across the country. Reliance Communications and Bharti Airtel uses the DLC technology for providing these services. With the introduction of broadband technology, the load on bandwidth is being absorbed by ADSL. ISDN continues to be an important backup network for point-to-point leased line customers such as banks, SAVAR centers, Life Insurance Corporation of India, and SBI ATMs. Japan. On April 19, 1988, Japanese telecommunications company NTT began offering nationwide ISDN services trademarked INSNet64 and INSNet 1500, a fruition of NTT's independent research and trial from the 1970s of what it referred to the INS. Previously, on April 1985, Japanese digital telephone exchange hardware made by Fujitsu was used to experimentally deploy the world's first I-interface ISDN. The I-interface, unlike the older and incompatible Y-interface, is what modern ISDN services use today. Since 2000, NTT's ISDN offering have been known as FLET's ISDN, incorporating the FLET's brand that NTT uses for all of its ISP offerings. In Japan, the number of ISDN subscribers dwindled as alternative technologies such as ADSL, cable internet access, and fiber to the home gained greater popularity. On November 2, 2010, NTT announced plans to migrate their backend from PSTN to the IP network from around 2020 to around 2025. For this migration, ISDN services will be retired, and fiber optic services are recommended as an alternative. United Kingdom. In the United Kingdom, British Telecom provides ISDN 2E as well as ISDN 30. Until April 2006, they also offered services named Home Highway and Business Highway, which were BRI ISDN-based services that offered integrated analog connectivity as well as ISDN. Later versions of the Highway products also included built-in universal serial bus sockets for direct computer access. Home Highway was bought by many home users, usually for internet connection, although not as fast as ADSL, because it was available before ADSL and in places where ADSL does not reach. In early 2015, BT announced their intention to retire the UK's ISDN infrastructure by 2025. France Telecom offers ISDN services under their product name Numerous, of which a professional duo and HomeIT version is available. ISDN is generally known as RNIS in France and has widespread availability. The introduction of ADSL is reducing ISDN use for data transfer and internet access, although it is still common in more rural and outlying areas, and for applications such as business voice and point-of-sale terminals. In Germany, ISDN is very popular with an installed base of 25 million channels. Due to the success of ISDN, the number of installed analog lines is decreasing. Deutsche Telekom offers both BRI and PRE. Competing phone companies often offer ISDN only and no analog lines. However, these operators generally offer free hardware that also allows the use of POTS equipment, such as NTBAs with integrated terminal adapters. Because of the widespread availability of ADSL services, ISDN is today primarily used for voice and fax traffic, but is still very popular thanks to the pricing policy of German telecommunication providers. Today ISDN and ADSL, VDSL are often bundled on the same line, mainly because the combination of ADSL with an analog line has no cost advantage over a combined ISDN-ADSL line. Some German operators started to implement next-generation networking, generally realized via DSL and unbundled local loop. However, a few operators offer the same services via the cable television infrastructure or, in selected areas, via FTTH. Because of the popularity of ISDN, virtually all these telecommunication providers bundle their products with residential gateways that include both integrated analog telephony adapters and ISDN-NGN adapters. CCITT, the incumbent telecommunications operator, offers ISDN-BRI services in Greece. Following the launch of ADSL in 2003, the importance of ISDN for data transfer began to decrease and is today limited to niche business applications with point-to-point requirements. International deployment. A study of the German Department of Science shows the following spread of ISDN channels per 1,000 inhabitants in the year 2005. Norway 401, Denmark 339, Germany 333, Switzerland 331, Japan 240, UK 160, Finland 160. Sweden 135, Italy 105, France 85, Spain 58, United States 47. Configurations. In ISDN, there are two types of channels, B and D. B channels are used for data, and D channels are intended for signaling and control. There are two ISDN implementations. Basic rate interface, also called basic rate access, consists of two B channels, each with bandwidth of 64 kbit per second, and one D channel with a bandwidth of 16 kbit per second. Together these three channels can be designated as 2B plus D. Primary rate interface, also called primary rate access in Europe, contains a greater number of B channels than a D channel with a bandwidth of 64 kbit per second. The number of B channels for pre varies according to the nation. In North America and Japan it is 23B plus 1D, with an aggregate bit rate of 1.544 mbit per second. In Europe, India and Australia it is 30B plus 1D, with an aggregate bit rate of 2.048 mbit per second. Broadband Integrated Services Digital Network is another ISDN implementation, and it is able to manage different types of services at the same time. It is primarily used within network backbones and employs ATM. Another alternative ISDN configuration can be used in which the B channels of an ISDN-BRI line are bonded to provide a total duplex bandwidth of 128 kbit per second. This precludes use of the line for voice calls while the internet connection is in use. The B channels of several BRIs can be bonded. A typical use is a 384K video conferencing channel, using bipolar with 8/0 substitution encoding technique, called data is transmitted over the data channels, with the signaling channels used for call setup and management. Once a call is set up, there is a simple 64 kbit per second synchronous bidirectional data channel between the end parties, lasting until the call is terminated. There can be as many calls as there are bearer channels, to the same or different endpoints. Bearer channels may also be multiplexed into what may be considered single, higher bandwidth channels via a process called B-channel bonding, or via use of multi-link PPP bundling, or by using an H0, H11, or H12 channel on a pre. The D-channel can also be used for sending and receiving X25 data packets, and connection to X25 packet network. This is specified in X31. In practice, X31 was only commercially implemented in UK, France and Japan.